So we need a method that's going to always work. So we have something called the quadratic formula, and it does always work no matter what kind of quadratic I give you. The difficulty is that you tend to make sloppy mistakes, and the order of operations in cleaning it up is also a place where you make mistakes. So I will only use it if something is not factorable. In other words, if either method 1 with factoring or method 2, the square root method, doesn't work, then I'm going to come in and use the quadratic formula. It is a formula, and it's one you should already have memorized. So I'm going to call it the QF for quadratic formula. And it simply says that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And again, the a, the b, and the c refer to that standard form of ax squared plus bx plus c equal to 0. So a is the coefficient on the first term, b is the coefficient on the second term, and c is the constant. So let's go try it, see how it goes. This is example 4, part A, and our quadratic equation is 2x squared minus 8x minus 5 is equal to 0. Now, what I would do first is I would check 2 times 5 is 10. I'm looking for factors of 10 that subtract to 8. Well, there aren't any. The factors of 10 are 10 and 1 and 2 and 5. They do not subtract to 8. So it's not factorable. So I would either have to complete the square, which would be a little ugly, might be okay, or I could use the quadratic formula. We're trying to do the quadratic formula here. So just as a reminder, A is the 2 that's out in front, B is that negative 8 on the middle term, and C is a negative 5. You'll notice we're including the signs as we do this. So our formula says we're going to do the opposite of B. Well, B is a negative 8. We're going to take its opposite. That would be a positive 8, plus or minus the square root of negative 8 being squared. That's the B squared. Minus 4 times 2 times negative 5, all over 2 times a, which is also 2. Again, the order that you clean this up in is very, very specific. Make sure you follow it religiously to do it correctly. We're going to do the inside the radical first. Watch your signs. A negative 8 squared is always a positive 64. Negative 4 times a negative 5 is going to give me a positive, so I know this is plus. 4 times 2 is 8 times 5 is 4. So I need to put 64 plus 40 all over 4. That would be 8 plus or minus the square root of 104 all over 4. The next step, once you've got the radical down to a single term, is to simplify that radical. Well, 104 is 4 times 26. So I know I can square root the 4. So now we have the 8 out in front. The square root of 4 is 2. Left on the inside of the radical is 26 all over 4. Still not done. We now need to reduce the fraction. So we're going to notice that the 8, the 2, and the 4 will all divide by 2. So I'm going to come in and divide all these by 2. If that's a little confusing, what you can think about is factoring 2 out of the numerator and then canceling that 2 with what's in the denominator. So 4 plus or minus the square root of 26 all over 2. So I divided this 2 and this 4 both by the 2. That leaves me with the 2. And that's our final answer. So we get 4 plus the square root of 26 over 2 and 4 minus the square root of 26 over 2. Now, if I completed the square, I would get the exact same answer. So, but again, the order of cleaning this up is really, really important. So again, we did what's inside the radical first. We did the squaring. That will always be a positive because you're squaring a negative number. Watch your sign in between the two terms. So in this case, the negative times the negative gave us a positive. So 64 plus 40 gave me 104. I then simplify the square root of 104. And then the last step is to reduce the fractions. Make sure you draw that fraction bar under everything. So it's not just the root 26 over the 2, the 4 is also over 2 also. Okay, let's try another one just for practice. This is example B. So part B says a quadratic equation this time is 3x squared plus 2 equals 4x. So the first thing to notice is it's not in standard form. And in order to pull out the A, the B, and C correctly, we need this in standard form. So I'm going to move over that 4x, making sure I put it in the middle. Standard form says descending order. That means the exponents count down. There it is. So this time when we go to the quadratic formula, A is 3, B is a negative 4, C is 2. I'd like to point out that again, 3 times 2 is 6. There are no factors of 6 that add to 4, so it would not factor if I tried that method. So x is equal to the opposite of b. That's going to make that a positive 4 again. Plus or minus the square root of a negative 4 squared minus 4 times 3 times 2. So there's 4 times a times c all over 2 times a. Inside the radical, that negative 4 squared is positive 16. 4 times 3 is 12 times 2 is 24. So that's 16 minus 24 this time, all over 6. So that's equal to 4 plus or minus 16 minus 24 is a negative 8, all over 2. Whoops, no, all over 6. Make sure you copy correctly from line to line. Okay, so to simplify that, I'm going to recognize that that's 4 times 2, but because of the negative, I also know that the square root of a negative 1 is an I. So I have 4. The square root of the 4 is going to give me the 2. I'm going to pull the I out as the square root of the negative. Left over on the inside is a 2, all over 6. Now I'm going to recognize that the 4, the 2 that's on the outside is 6, so I'll divide by 2. So we'll divide that 2 out of there. We get 2 plus or minus I root 2 over 3. So that's our answer. The problem is that in this section of the textbook, they're not looking for non-real solutions because this involves I. It's a complex solution and it's not real. So this is a non-real solution. And the book is not going to look for that. So in terms of an answer, it says non-real solution. So, and we knew that actually right here, the minute we ended up with that negative under the radical, I knew that they were not going to be real solutions. But I wanted to walk on one all the way through because in later chapters, we're going to need those. So that's how we would use it. So again, we followed our order of operations in cleaning up that's radical and the actual quadratic formula itself. So again, it will always work, but there are plenty of places to make sign errors, arithmetic errors, those kinds of things. So be careful when you use it. So again, we don't use the non-real. So in the handout, it specifically says in this section, we'll focus on finding the real solutions and the complex solutions, those involving I to later chapter. It is interesting to note that the non-real solutions come from looking at what's under the radical, that b squared minus 4ac is called the discriminant. So it tells us the nature of the solutions. So the discriminant, one of those words that I always have to make sure I spell correctly for discriminant, is the b squared minus 4ac, and it tells us what kind of answers we get. So if it's positive, I'm going to get 2 real solutions. If it's equal to 0, then I get 1 repeated real solution. And if that inside part is negative, I'm going to get non-real solutions. I'll get 2 complex solutions. So example 5 says to use the discriminant to determine whether each quadratic equation has 2 unequal real solutions, a repeated real solution, or 2 complex solutions. So we have 2x squared minus 6x plus 7 is equal to 0. I'm not solving it. They're not asking me to solve it. They just want to know what kind of answers we're going to get. So we literally just need to look at b squared minus 4ac and see what that comes out to be. So b squared would be that negative 6 squared minus 4 times 2 times 7. So that would be 36. 4 times 2 is 8 times 7 is 56. So that's going to give me a negative 20, which is less than 0. And that tells me that I get 2 complex solutions. So they are non-real solutions. So I would be taking the square root of a negative 20. So they're going to involve I. Part B on that example says, what if we have 3x squared plus 5x minus 8 is equal to 0? So again, looking at the b squared minus 4ac, that would be 5 squared. For the first time, it's a positive 5 squared. Doesn't make a difference. It's going to be a positive number. Minus 4 times 3 times negative 8. So that it would give me 25. The negative times the negative is going to make that a positive. 4 times 3 is 12 times 8 is 96. And 25 and 96 gives me 120, which is greater than 0. So we get a positive under the radical. That tells me I get 2 non-repeated real solutions. So I think your book uses the word meaning that they're different answers and solutions, but they are real numbers. And that's how we can use the discriminant. So it's a nice quick way to see whether or not you're going to get I's as part of your answer or not. It's useful for when we go to do parabolas, because if we end up with I's and non-real solutions, then that means that we're not crossing the x-axis. So it's kind of a useful tool. We use it off and on. And then finally, at the end of this section, are a couple of application problems. Just to remind you that yes, life is a word problem. So this is example 6, our final one for this section. And it says the area of the opening of a rectangular window is to be 143 square feet. So we know the area is 143 square feet. The length is 2 feet more than the width. Length is 2 feet more than the width. What are the dimensions? So the very first place I'm going to do is I'm going to come and draw myself the window. And we know that its overall area is 143 square feet. I also know that the length is 2 feet more than the width. So if I come in and call this W for the width, then this side down here that is the length is 2 feet more than that. So I have W plus 2. Well, we know that the formula for the area of a rectangle is its length times its width, but its length is W plus 2. Its width was just W, and we know that the area is 143. So now we've written an equation, and it turns out to be a quadratic equation. So we have 143 is equal to, I'm going to distribute the W here. That'll give me W squared plus 2W. I need this in standard form, so I'm going to move everything to the same side. So 0 equals W squared plus 2W minus 143. Now you're going to ask yourself, why didn't I move everything to the left side? Because that's what all the other examples were. Well, because I want to make sure I keep the W squared positive to help with the factoring process. So I'm going to check factoring to see if it works. Are there factors of 143 that are going to subtract it to? Well, I think there are, because I think my window is going to have nice dimensions, not weird dimensions. So I noticed that 143 is odd, and I need two numbers that are fairly close together. So I'm just going to take 143 and divide it by an odd number. So I'm going to divide it by 9. That doesn't work. And then I'm going to try dividing it by 11. Notice I didn't start with a small odd number. I need them to be close together, so that means it's fairly large. And sure enough, if I take 143 and divide it by 11, it comes out to be 13. So 11 times 13 is 143. When I subtract those two factors, I'm going to get my 2. So I factors pretty quickly. I guarantee that I can do that quicker than you can do the quadratic formula. So this factors into W plus 13 and W minus 11. And the 13 is positive because we need it to be positive. We get the plus 2 in the middle. It's the larger factor. So when you solve those, you're going to get W equals a negative 13. You're also going to get W equal to 11. Can't have a negative dimension, so we're not going to look at it. But we now know that the width is 11. Because that's what our W stood for in our picture, so it's 11 feet. But we also need the length. And the length we know is 2 feet more than that, so that's going to be 13 feet. So that's one of those weird quirks of quadratics that sometimes the answer that you took out as a negative, because it was a negative, ends up in its positive format as an answer. So there it is. So the dimensions of the window are 11 and 13 feet. And those are quadratic equations.